Okay, here's a video answer key for the review on adding and subtracting fractions. So on the first page, it's all just adding. So if we look at the first one, 3/10 plus 5/10. Now the denominator, the number on the bottom, represents how the whole is divided up. So this whole is divided into 10 equal pieces. And this one has 3 of those 10. And we're going to add 5 of those 10. So in total, we're going to have 8/10, which can be reduced to 4/5 since both 8 and 10 are divisible by 2. In B, we have same denominators again, so we can just go ahead and add the wholes. 2 wholes plus 4 wholes, so that's 6. And then for 2/3 plus 2/3, that'll give us 4/3. Now, 4/3 is actually equivalent to 1 1/3. And so this is kind of like 6 plus 1 1/3, which would equal 7 1/3. Now in C we have different denominators, so we're not able to just add these. So we have to make sure they have the same denominators. If I'm looking at these two denominators, 5 and 10, and looking for common multiples, well, multiples of 5, multiples of 10, I can see that 10 is a common denominator, or a common multiple, sorry. So that's what I'm going to make the denominator. In order to make 3/5 written as a fraction divided by 10, I have to multiply both the numerator and denominator by 2. And so I'm left with 6/10 plus 5/10. And now I can just add because I have the denominators the same. So I get 11/10 or 1 1/10. And the last question here on this side, you can see the denominators are different. So once again, I have to make common denominators. And so in this case here with 5 and 4, the lowest common denominator would be 20. And so I'm going to multiply both the numerator and denominator by 4, so that's like kind of like multiplying it by 4 over 4, which is just 1. I'm not changing the value of this. I'm just breaking up this whole into smaller pieces. I'm breaking it up into 20ths instead of fifths. So that leaves me with 8/20. And here I have to multiply them by 5 over 5. So that'll give me 4 5/20. So I'm going to add the wholes first. 2 plus 4 is 6. And then add the numerators, so that's 13/20. E, I can see that all of the denominators are the same, so my job's not so bad here. I can just add the numerators, so I have 1/12 plus 7/12, so that's 8/12, and then another 7/12, so that'll give me 15/12 in total, and that equals 1 3/12. And 1 3/12 can be further reduced because both of these values are divisible by 3, so it can be 1 1/4. In F, I have different denominators, so I need to get a common denominator here. If I list the multiples of 3, multiples of 12, multiples of 4, I can see that 12 is a common multiple, so I'm going to make all of these fractions written over a denominator of 12. And so to do that, I'd have 4/12 instead of 1/3. I have 7/12, just keeps the same. And this one I have 21/12. And then now that I have the denominators the same, I can just add the numerators. So 4 plus 7 is 11, and 11 plus 21 is 32/12. 12 goes into 32 2 times, so I make 2 wholes, so that's 24. And then I have an additional 8/12 left over, and that can be further divided because both these values are divisible by 4. So that's 2 2/3. So this is the best answer in lowest terms. In G, I can see that there are different denominators here. If I were to list the multiples of 6 and of 9, I can see that 18 is the lowest common multiple. So I'm going to try to get them to 18, which means that for 6, I need to multiply it by 3. I need to multiply these by 2 over 2. So I'm left with 7 15/18, and 2 2/18. 7 plus 2 is 9, and 15 plus 2 is 17. So I have 9 17/18. Last question, I can see that these two are not the same denominator. Now 10 and 15, I can see that they're both multiples of 5. So if I were to list some multiples, I can see that 30 is a lowest common denominator here. So to get to 30, I need to multiply by 10 by 3 and 15 by 2. And I'll do that to the numerator as well so that I'm making sure that they're the same, that they're equivalent fractions. So that's 7 and 15 30ths and 2 and 6 30ths. And now I can add, since the denominators are the same. 7 plus 2 is 9. 15 plus 6 is 21 30th. Now, 21 and 30 are both divisible by 3. So it's the same as 9 and 7 tenths. Now the second page is subtraction. So we're going to be subtracting all these. The first one here, we have the same denominator, so I can just go ahead and subtract. I have 8 tenths and I'm going to take away 6 tenths, so I'm left with 2 tenths. And that can be reduced to 1/5. Since both 2 and 10 are are even numbers, they're both divisible by 2. In B, we have common denominators as well, so 6 minus 5 is 1. 2/3 minus 1/3 is 1/3. Now in C we have different denominators, so I have to make them have common denominators. So I'm going to make them with a denominator of 20. So I have 15 over 20 minus 8 over 20. 15 minus 8 is 7, so 7/20ths. And for D, I need to have common denominators. A common denominator between 6 and 3. Well, 6 is actually a multiple of 3, so I'm going to change this one into 2/6 instead of 1/3, because 1/3 and 2/6 are equivalent fractions. And so I'm going to rewrite this so that I have the same denominator. And 6 minus 5 is 1, and 6 minus 2/6 is 3/6, but 3/6 is actually the same as 1/2. Okay, in E, same denominator all the way through, so I can just subtract the numerators. I start with 11 and I subtract 2, so now I'm at 9, and then 9 subtract 5, so I'm at 4/16, and 4/16 is the same as 1/4 because both 4 and 16 are divisible by 4. For this one here, they're the same denominator, so I both have 6 here, but I have a little problem because in this case I can't really go 7 minus 2 and then 3/6 minus 5/6. So I can't do 3/6 minus 5/6 because you can't take away 5 from 3 here unless we want to talk about going into negatives, which is one way you can do it. Another way we can do it is to regroup or borrow from the wholes here. That's kind of like if I were to have 7 wholes and a 3/6, which is basically like a half in a way. So I have 7 and 3/6, and instead I'm going to chop this neighboring whole up into 6ths as well. So now I have 6 wholes and 9/6. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I do that, now I can just carry on with my normal procedure. 6 subtract 2 is 4, 9 subtract 5 is 4, and 4/6 is the same as 2/3. So that's one way I can do it. Another way you can do it is if you were to say 7 subtract 2 is 5, and then 3/6 minus 5/6, that would be like negative 2/6. Now I have 5 wholes and I'm taking away 2/6, so that would leave me with 4 and 4/6. So that's another way to do it. You'd get the same answer and you'd reduce it to 4 and 2/3. For this one here, I can see that I have different denominators, but 16 is a common multiple of 8 and of 4, so I'm going to multiply in order to get common denominators. So I have 11/16, subtract 6/16, subtract 4/16. 11 subtract 6 is 5, and 5 subtract 4 is 1. And for the last one, I have 10 and 5 as my denominators, so they're different denominators, so I need to make sure that I make them the same. And 10 is a multiple of 5, so I'm just going to write them both over 10. So I have 7 and 3/10 subtract 2 and 8/10. Now, once again, 3/10 is smaller than 8/10, so I can't just carry out the normal procedure, 7 minus 2 and then 3/10 minus 8/10. I have to do either regrouping, so instead of 7 and 3/10, it would be 6 and 13/10. And then I can say 6 subtract 2 is 4, and 13 subtract 8 is 5, and that's really just 4.5. Or if I want, I could say, well, 7 subtract 2 is 5, and actually I'll go from here, sorry, 5, and 3/10 subtract 8/10. Well, 3 subtract 8 is -5, so this is -5/10. So this is like I have 5 wholes and I'm taking away 5/10 or a half. So 5 subtract a half would leave me with 4.5, which is what we got down here. Okay, for the word problem, there's basically 4 things I'm looking for. First thing is to set up the statement. Is this an addition or subtraction statement? So it takes Nadia 5/6 hours to complete her English homework and 11/6 hours to complete her math homework. How long does it take to complete all of her homework? Now this is referring to a total or all together, so we're dealing with an addition statement here. So I'm going to write out the addition statement, 5/6 plus 11/6. Now these ones actually have common denominators, so 5 plus 11 is 16. So I'm left with 16/6, which is the same thing as, well, 6 goes into 16 2 times and 4/6 left over. Now I could reduce this to lowest terms, but I'm actually going to leave it because this is sort of the same thing as 2 and 40/60ths. And the reason why I like this is because we're dealing with time, right? And so in this case here, it takes Nadia 2 hours and 40 minutes to complete her homework. Now I can say 40 minutes because it's out of 60 and there's 60 minutes in an hour, so that's why it would work that way. You could also reduce it to 2/3 and say 2 2/3 of an hour if you wanted to. Notice it's a word problem, so I'm also including a concluding statement that answers this original question. Okay, on the last page we have 2 more word problems. So Michael walks 2.5 miles each day. 2.5. He has already walked 3/4 of a mile. So let's picture this. So every day he walks 2.5 miles, and he's already walked this far. He's already walked 3/4 of a mile. How much further does he have to walk? Well, that's looking at what the difference is, what's remaining, right? So that's a subtraction statement. So 2.5 subtract 3/4. These do not have the same denominator, so I need to make them the same denominator. So 2 1/2 is the same as 2 2/4. And then I can either regroup this to make it 1 6/4. So that would be 1 3/4. Or from this stage here, I could say, well, 2 subtract 0 is just 2. And then 2/4 subtract 3/4 is like -1/4. So if I had 2 wholes and I take away 1/4, I'm left with 1 3/4. So therefore, he still has to walk 1 3/4 miles. So the next one's kind of a similar question. Esther walked 1.5 miles, so she already walked 1.5 miles to the park. So she goes here to here, it's like 1.5 miles to the park. And then she walks 3/10 of a mile to her friend's house. And it says, how far did she walk? And we're kind of looking at how far did she walk in total. So in this question here, this is an addition problem. So we have 1.5 miles plus 3/10. Now once again, we don't have the same denominator, but I know that 1/2 is the same as 5/10. So I'm going to write it as equivalent fractions so that we can have common denominators. And I have 1 8/10 or 1 4/5. So therefore, Esther walked 1 4/5 miles. Now for these last two questions, I want you to take this number. So in this case, it's 2.5 or 5 halves or 10 quarters or 15 sixths or 20 eighths and so on. Notice I've taken this original number and I've written it in various different ways. This is sort of a strategy for these types of questions. So you have lots of different ways to make your sums. Because it says sum, we're dealing with addition and two fractions. So I'm looking for some fraction plus some fraction equals 2.5. Now I'm looking at 28ths because that I feel like I have the most room with that one. So I could say like 19/8 plus 1/8. 19/8 plus 1/8, that's going to be 28ths, which is the same as 2.5. So here's one way that I can do it. And I can do a whole bunch. I can do 18/8 plus 2/8 and 17/8 plus 3/8 and so on and come up with a whole bunch of different solutions. But consider this part. Try to have some pairs that have different denominators as well. And so when I went to 18/8 plus 2/8, you might have recognized that 2/8 is actually the same as 1/4. So I could say 18/8 plus 1/4. So there's another way to get it. Or I could say 18/8 is the same as 9/4. So I could say 9/4 plus 2/8. So there's a whole bunch of different ways that you can create these sum. I'm sure you can come up with lots as well. And then for the last question, it's the same number. So 2.5 or 5 halves or 10 quarters. These are all equivalents, 15 sixths. But this time it's the difference, which is subtraction. So we want some number, subtract another number, equals, let's say 15 sixths. I'm going to take this one instead. Try to come up with some different denominators. Well, I'm going to start with just the same denominator for now. So I'm going to write them all over 6. So I might say 16 sixths minus 1 sixth. Well, there's 1, okay? Now if I want different denominators, I might recognize that 16 sixths is the same as 8 thirds. So I could say 8 thirds, subtract 1 sixth. There's one way. And then maybe I might say 14 sixths, sorry, not 14 sixths, 18 sixths minus, well, if this was 18, I'd need to subtract 3 sixths. So 18 sixths is the same as 3 wholes minus 1/2. I did say in class, try to avoid making wholes like this. So maybe I'll skip that one. I won't put that as one of my 4. So I can go maybe to 26. For 26, what would I need to subtract? 5 sixths. And 26 is the same as 10 thirds. So I could say 10 thirds, subtract 5 sixths. And so I'm using one of these equivalents and I'm creating statements that are true. And then I'm taking those fractions and I'm making equivalents that have different denominators. And that's what's really going to take you to the mastery level. So that's the example questions and the review questions and answer key. If you have any questions, please email me. And the test will be tomorrow, and it'll be a little bit shorter than this review. It's only 2 pages instead of 3. Okay, happy studying.